Section 6.4, rational exponents. We're going to simplify them. Rational exponents just means fractional exponents. So let's simplify the first couple. 216 to the 1/3. What you have to know is the number on the top of the fraction is on the inside of the root. The number on the bottom is on the outside. So it's inside over outside when you're talking about the fraction. Inside over outside. So a 216 to the 1/3 power is the same as the cube root of 216. Now, what the book does is they look for a number that's times itself 3 times to get 216, but we all kind of know that our calculators can do it if it works out to be a regular number. So grab your calculator, check out the cube root of 216. And it is 6. So here's what the book will do. They do the whole factor tree thing. So what if you get to one that you type in and it doesn't work? Here's what you would do then. So I'm going to show you this one, but if it doesn't work, you can simplify parts of it and then the rest stays inside. So 216, let's see, I'm going to multiply, I'm going to go out by 4. So 216 is 4 times 54. 4 would be 2 times 2. 54 is 6 times 9. 2 times 3. 3 times 3. Now with a 3 on the outside, we need how many numbers to take it out? 3. So we need 3 2s, 3 3s in order to take it out. We do have that. So it comes out as a 2 times 3, which is 6. So just in case you get one that doesn't simplify all the way, you're going to factor tree it just like we've done. As long as you've got 3 of the same number, you can take it out. If you've got multiple numbers you can take out, you multiply them on the outside. Let's say there was another 2 left over, then it would be 6 cube root 2. Some of you are forgetting this little root number. When you simplify, if it's still there, it doesn't turn into a square root. It stays whatever it is. So just be careful there. Just probably an oversight, but I just want to make sure that you know that it is still the same root that it was at the beginning. So let's try 7 to the 1/2 power times 7 to the 1/2 power. We're going to convert both of them into the radicals. So this is like the square root of 7. It would be the square root of 7 to the first. The 1 goes on the inside, the 2 goes on the outside, times the square root of 7. Well, when we have 2 7s underneath a square root, what is it? 7. Okay, and remember square root of 7 times square root of 7 is like the square root of 49, and we know that the square root of 49 is 7. Okay, let's try one more. This is like the 4th root of 5. I usually don't write the ones, by the way. If you want to write the 1, go for it. It would be 5 to the first and then the 4th root of that, or the 4th root of 5 to the first. This would also be the 4th root of 125 to the first, or the 4th root of 125. I'm going to factor tree 125 because I know that that is not simplified. That would be 25 times 5. Okay, now do we have enough right there to take it out? We don't. But could we put them together and have enough? Then we can. So what I'm going to do is I'm going to put all of these together. So I really have the 4th root of all of these, right? Because there's 3 more in the next one. So it kind of looks like that. If you know you have 4 of them with all of it together, just write it. You can just write it as a 5. If you don't, you can certainly put them all under the same one and then group them in 4s. Whatever you need to do there is good. Basically, what you want is you want the exponent on the inside to match the one on the outside, because then it's kind of like they undo each other, and then you just get the number. Yep? Not on this part, no. Okay. So we are looking at, usually when they do these exponents, the fractional ones, you'll have a negative in there or you'll not have a negative. You know what I mean? So you're not going to change it to suit both of them. Okay, and you do have to kind of show some work. So try this just as a check. Do 5, caret key, 1/4 in parentheses. So it's like you're raising it to the 1/4 times 125 caret 1/4. See if it gives you 5. Now, what? You're just typing in this. Just make sure the 1/4 are in parentheses using your caret key, that little hat-like thing. I just want to check to see if it gives you 5, okay? But just because your calculator gives you 5 doesn't mean you don't have to show something. So you would have to show something like this, and then you could put the 5. Okay, so you still have to show it, but you can certainly check it using your calculator too. And you always want to take it from a fractional exponent to a radical because we know how to do those. The fractional exponents in our head we're not really good at because we haven't had them much before. Okay, let's see if you need this. You might want to write these. And of course it ends up over here. It's just different ways of writing fractional exponents, and it's the same as what we just talked about. So if you get the whole inside over outside thing, you'll be fine. This a to the m over n, inside number, outside number. So they put the m inside, the n outside. This is another way to write that. Sometimes it's good to do the root part first and then take the exponent. Sometimes it's better to take the exponent first and then the root. So it's basically the order that you're doing them in. And that's really all that this one says. So we're going to do x to the 3/7 and y to the negative 3.5. So what do you do when they're in fractional exponents? What do you do when they're in decimal exponents to get them as a radical? Does everybody have that? Okay, I'll just kind of put it right there. So what number's on the inside of the 3 and the 7? The 3. So it kind of looks like this. It's going to be 3 goes on the inside, 7 goes on the outside. Is there anything else we can do with that one? There are not 7 x's, right? So we can't do anything else. So basically it's just getting used to where do you put the numbers. So for this one, this is your answer. If they were switched, then you could do more. You know, if the 3 was on the outside and the 7 was on the inside. Now, what about if you have a decimal? This right here, if you type it in your calculator, type in negative 3.5, change it into a fraction, then we will put the numbers where they belong. So it doesn't matter that it's a decimal because we can convert it anytime we want. And I want it in improper form. You can't do mixed form on these. So negative 3.5 would be the same as negative 7 over 2, right? Did you get negative 7 over 2? Okay, if you put it as mixed, where do you put the whole number? Okay, so you got to do improper fraction in order for it to work. Which number goes on the inside, the 7 or the 2? Okay, so we're going to go y to the 7, and I'll go, let's do this first. Do you guys remember in Algebra 1, when you had something like this and you wanted to make it positive, what did you do with it? You brought it down to the bottom. Do you remember when you had to flip them kind of back and forth? That's what we kind of need to do here. So this would be the same as 1 over a to the 7. If it was negative on the bottom, to make it positive, you would bring it up. We can't do these negative exponents like they are, so you want to make them positive first. So for this one, I'm going to go 1 over y to the 3.5 first. Then we converted it to 7 over 2, and now we're going to put it in radical form. So 7 you said was inside, 2 was outside, and you don't need to write the 2 unless you want to. Could we simplify this one? Yeah, because we've got a bigger number on the inside than we do on the outside. How do we simplify that? How many y's are going to come out? There's going to be 3, right? So think of it like this. We have, here's a pair, here's another pair, here's another pair. Or 7 divided by 2 gives you 3 whole parts, right? And you have another part left. So we're going to have a y cubed on the outside. And then we'll have 1 y left. Now, can we have radicals in the denominator? No. So now we have to fix that. So I'm going to do a different color here for a second. So I don't like this part right here. To get rid of that, we need to multiply it by the square root of y. The y cubed means nothing because that's not in a radical. It's only the parts that are in a radical. The rest can stay on the outside. So then we simplify a little bit more. So I'm going to erase these now. Okay. So 1 times square root of y on the top would be square root of y. On the bottom, we would have a y cubed. And then what's square root y times square root y? Y. Which makes it square root of y over y to the 4.
Why do we have to multiply by y?
Because you can't have square roots in the denominator.
And then,
No roots at all.
oh, since
I
you
sh-
multiply the top, you have to multiply the bottom.
Yep. No, I should say no roots instead. No roots in denominator. So you have to rationalize it, whatever that happens to be. Okay, so this time they want us to take it from a radical form to a fractional form. So when it says exponential form, it just means fractions. Okay, so which number's on the inside, which number's on the outside? Okay, and remember it's not a 1 on the outside, it's a 2. So it's 5 over 2. And that's all you can do there. You're just changing it into an exponent because that's what they want. And then what would the other one be? 3 over 5, because remember this is that alternate form. If they wanted to, they could have tucked this 3 underneath it, but they separated it. So they're doing like the root part first and then the exponent. But remember, any of those small numbers on the outside are always on the bottom. Any of the other ones are on the top. So it's 3 over 5. And that's all you can do. So those are actually the easiest ones because usually there's nothing you can do to simplify. You're just changing it from one to the other. It's the radical ones that you probably would have to simplify. Okay, here it is just reminding you about what we can do with exponents. I would probably maybe write these. It gives you an example, and you might want to write those other properties as well. It's just reminding you what you can do with exponents. If you have two numbers that are the same base, those a's have to be the same. If they are the same, you can add the exponents together. Anytime you have parentheses, it just means multiply those. So parenthesis to a parenthesis, it's just like kind of like a distributive property, or parentheses just when you multiply. If you have two things in the parenthesis to the same power, it's both of them to that power. So it would be a to the m times b to the m. This time you can't put them together because the a and the b are not the same. So in order to do anything else for that one, those variables should be the same. Then we go to how do we make exponents positive? We bring them down. So we talked about that already. How do you actually put these together? You would bring this up, and if you brought it up, it would be like subtracting the exponents. Some of you, I think yesterday or the day before, remembered that if you are dividing numbers with the same base, you subtract their exponents. And then this one kind of works the same as when you're multiplying. If you have a fraction to a power, it would be that power to both of those parts. So a to the m over b to the m. So same properties that you've already seen, it's just that you haven't seen them for a while. Okay, so here is kind of the place that we're still going to be practicing how you reduce these things. What do they look like? So for me, I look at the x's there and know that the bases are going to be the same, so we got to figure out how can we put those things together. You can do some things with exponents, but looking at a fourth root and an eighth root, could we put them together like they are? No. So remember when you have, if you had a 2 fourth root of 7 minus 3 fourth root of 7, you could put them together right away. These are not the same right away, so you can't really do that. So how do we get these in forms that we can use and can put together? I'm going to turn them into fractions first because we know kind of what to do with them. So what is the top number of the top radical? Okay, so it's going to be like a 3 over 4. I'm going to do the same thing with the one on the bottom. So the top number is the 2 or the 8? 2. Now, what do we do when we divide numbers with the same bases? Subtract the exponents, okay? Or you can think of it like this. If I want to bring this up, I would make it negative, wouldn't I? And that would mean the same thing as subtracting the exponents. So it looks like this. X to the 3 over 4 minus 2 over 8, and 2 over 8 is like 1/4. So I'm going to reduce that right now. That gives you x to the 1/2. And they do put it back in radical form at the end. So an x to the 1/2 would be like an x on the inside to the first. You can write the 1 if you want to, and then a 2 on the outside. And again, you can write the 2, but you don't have to.
Will you say usually if you want it to be
If they start in radical, they're usually turn it back into a radical when they're done.
Okay.
You can kind of just assume that. I'll go like this, start and end in radical form. Okay, so numbers are the same base, subtract their exponents when you're dividing them. So here's a couple more. 16 to the negative 2.5 and negative 32 to the 4 over 5. Since this one's in a decimal, I would turn the decimal into a fraction first. So this one would be 16 to the what?
This is like, how do you change like a decimal to a fraction?
Look for your F to D key. It's usually like diagonal from your second function key.
Okay.
So put in there negative 2.5, second FD. It'll either change it from a decimal to a fraction or back. And I got 5 over 2 as well.
Okay, and then this one is burned, no.
Okay, everybody else find it? And I guess I can look. So if you look at this calculator right here, the blue key in the far corner, look at the PRB key. It's right above that. Okay, so it's second function PRB key, and it should change it from a decimal to a fraction or back. Okay, so we have it as a fraction. It's negative though, so I want to make it positive. So what do? Yep, put it on the bottom. So now we're looking at 1 over 16 to the 5 over 2. Okay.
Wait, do we have to move it now because we don't have a radical?
It for some reason didn't write what I wrote. Okay. So we have a 16 to the 5 over 2. You can change it to a radical if you want to. You can keep it in fraction form if you want to. It kind of depends on what way that your brain is really wired. Usually the number that's on the bottom is the one that you want to try to kind of get rid of. But 16 in a radical isn't in its simplest form anyways, is it? So when you're looking at it, if you want to try to simplify a 16, it's probably going to go down to a 2, right? 2 to what power is 16? 4. So 2 to the 4th would be like 2 times 2 times 2 times 2, and you get 16. So I'm going to rewrite this one like this. Okay, or if you're struggling with how did you get 2, if you do a little factor tree, four twos. Okay, so same thing that we've been doing. If I simplify now, when I have an exponent to an exponent, what do I do with them? Multiply them, okay, because that's the rule that we just looked at. So 1 over, if I take 4 times 5 over 2, I get 10. And if you're not sure about that, take 4 times 5 over 2, should get 10. And now I'm going to go to my calculator and say, what's 2 to the 10th power? Okay, and I only know that because I just looked at it, so I don't know that many numbers in my head. So 2 to the 10 is 1024. It is going to be on the bottom, and we're going to leave it just like this.
So you have to simplify the bottom, 2 to the 4th, and then you do, for that answer, you do that as
Yes, and I just did the very bottom part. I didn't put it in as a 1 over. I did do 2 raised to the 10th power. Did you get 10, by the way?
Yeah.
Okay, so once you get 2 to the 10th.
So do you do 2 because that's what 16 was to 2?
That's what this is. So here, 4 times 5 over 2 is 10, and then 2 raised to the 10th power because that's what the base was. You keep it that way.
If we were to put that whole thing in our calculator, 2 to the 4th, parenthesis, and then with the exponent 5 divided by 2, would we get docked for not showing?
Yep. Do the multiplication because they gave us the rules above, so you got to kind of use the rules. This is another one of those that you might be able to get the answer on your calculator, but you got to show the work in between. So if you only get the answer, you're not going to get all the credit. Try 16 raised to the negative 2.5. It might give you a decimal. Then if you use your F to D key, it might change it to a fraction for you. I don't know. I never tried it, but it could be a big enough decimal that it doesn't. Does it work? No? Okay. So some of them work, some of them do not. Okay, so that was kind of a lot. So let's look at another one. Now, that one I kept in fractional form. What does it look like if you change it to radical form? What does it look like then? I'm just showing you 2 different ways. I think the book goes through both ways for each one. I'm just going to do fractions on the first one, radicals on the second one. If you understand the radicals better, do it that way. If you understand the fractions, do it that way. I probably won't say you have to do this one using fractions and this one using radicals. You're going to pick which one you like better. So let's stick to radicals for this one. The 4 is on the top, so that'll be on the inside. And the 5 will be on the outside. Now, this is one of those where if you know the 5th root of 32, use it. Okay, so I'm actually going to do that because I know what it is. I'm going to show you how to find it if you don't. I'm going to actually be doing this part first. And then I'm going to take that answer to the 4th. So 32. 8 times 4. 4 times 2. Oops. 2 times 2. 2 times 2. 1, 2, 3, 4, 5. So 2 to the 5th is 32. If I take a negative in an odd root, does the answer become negative or not? Like if you were doing the cube root of -8, wouldn't it be -2? So this is an odd root, so my negative's going to stay there for the time being. So I'm going to write it like this. 5th root of -2 to the 5.
Or can't they just take a 2 out and put it outside of the thing?
It's kind of what we're doing right now. So the 5th root of -2 to the 5, isn't that just -2? So you can write it. So if you know there's 5 and it comes out, take it out. Same thing. So we still have a -2, but we haven't taken it to the 4th power yet. So that's really the only thing we have to do. If we take a negative number to an even root, though, or an even exponent, then the negative kind of disappears. So that top number is really going to be the one that determines if the answer is negative or positive. If it's even, the negative will disappear. If it's odd, it will stay. 2 times 2 times 2 times 2 is 16. So one done using fractions, the other done using radicals. If the radicals throw you off, keep the fractions. It's not a super big deal. Whichever way you do it is totally fine, but you cannot go directly to the answer. You have to show the work in between. So we're going to reduce a couple more. I'm going to do the first one in fractions, the second one in radicals, just so you can see them one more time. Again, it doesn't matter which way you pick. Pick whatever's easiest for you. If the radicals throw you off, do fractions. Okay, so first one I'm going to do fractions. Okay, second one I'm going to keep it in radicals. So remember when you have a bunch of stuff to the 2/3 power, isn't it every single thing to the 2/3 power? So that's what I'm going to do first. So this is going to be like a -8 raised to the 2/3. It's going to be an x raised to the 2/3. And then this part right here, what fraction would those be? Inside number's 1, outside number's 2. Okay, so far. But then that whole thing is to the 2/3 because I haven't done those yet. So -8 to the 2/3, x to the 2/3, this to the 2/3. But this I wanted to get rid of that square root and I wanted to write it as fractions. Each of those then gets a half because it's they're both under the square root. Okay, so I'm going to take care of my variables right now. I'm going to leave my number for the time being. So I need to know, what do I do with these two numbers? When it's an exponent to an exponent, what do you do with them? Multiply them. So we're going to take x to the 2/3 was already there. We're going to leave that for now. 1/2 times 2/3. And I'm going to just tell you what I'm doing this time, and I'll simplify it in a second. And then the same for this one. So it's 1/2 times 2/3, just so you don't forget what to do with those.
Why did you bring the x 2/3 down?
I just showed you that I'm multiplying. If you know to multiply, just do it. I'm just kind of doing it so if you look back at it, you'd kind of know. So it looks like this. And I haven't done the 8 yet. So we have x to the 2/3, x to the 1/3, y to the 1/3. Now, what do you do when you have numbers at the same bases? What do you do with those? Add them. So 2/3 plus 1/3 would be 3/3. That's the same as 1. And the only thing I haven't done yet is the 2/3 thing. And this I don't do. We can do fractions. Let's do fractions since I started like that.
How did you, I'm so confused on where you added them.
Right here. I'm gonna write this on top. Add. Okay, it didn't change.
So there's like a multiplying symbol.
Yep. If you have numbers with the same base, like these, you add their exponents. So you're looking to compare those base numbers. If those are the same, you add the exponents. That's kind of where that's coming from. Okay, so here we have the x's that are the same, right? Since the bases are the same, you add the exponents. So I did 2/3 plus 1/3. I'm going to go like this. And we know that that equals 1. You can keep the 1, you can dismiss the 1, it doesn't really matter. So when we were doing fractional exponents before, we kind of did a little factor tree. So I'm going to do a factor tree with 8. 8 is 4 times 2 and 2 times 2. Notice how I have 3 of them. So this would be like this, negative 2 to the 3rd. So basically I rewrote negative 8 as negative 2 cubed. And when I have exponent to an exponent, I multiply them, and I get 2. And that gives me a 4 on the outside. Now, for some of you, you might want to do and I'm not sure here. I'm going to have to look to see if the book says make sure you leave it in simplified radical form. To me, it's like if it starts out as a fraction, leave it, but this has like a combination of both. Okay.
It has a fraction or...
Does it have both? Okay, so it says either or. Unless I say leave your answer in radical form, then it shouldn't matter. Okay, so you could do this one, or you could do that one. Now, for me, this does not come like super easy for me when you're looking at numbers. I feel like when you get to the number part of it, keeping them in radical form is easier. Okay, so I'm going to show you that on the next one. You could keep these all as fractions, you know, except for this part, and do this part a different way. Okay, so it kind of depends on what kind of makes more sense. So let's do one more, and this one we'll do with radicals instead. And I'm going to change color just so it kind of doesn't get mixed up. So for this one, first of all, it's a negative exponent, so what happens there? Move it down. So we're going to have 1 over 16y to the negative 8 to the 3/4. Okay, this is the same as 16 to the 3/4, And then what do you do with these again when it's exponent to an exponent? Multiply them. So you'd have negative 8 times 3/4. This right here becomes that. So the 3 stays on the inside, the 4 goes on the outside. Do you know the 4th root of 16? 2. Okay, so I'm doing the actual 4th root first, and then I'm going to cube it. So let's go like this. Let's keep the y to the negative 6 there too. So we have 2 cubed. And now we're going to simplify it, and we should be done. What's 2 cubed? 2 times 2 times 2.
Can we have a negative 6?
Nope, and we're going to take care of that right now. So what do we do when we have a negative in the denominator? Bring it up. So it's going to be y to the 6 over 8. This one won't have a radical because there's no radical like left. Unless you have a fractional exponent, it just stays like it is. So could you also go like this? 16 to the 3rd power, what is that? It's a huge number, right? Do 16 to the 3rd once. I don't know what it is.
4,096.
Okay, and then do the 4th root of 4,096. You should get 8. So it doesn't matter like which order you do them in. If you wanted to do 16 cubed, you would write the 4th root of 4,000, whatever it happened to be, and then I can tell that you're just doing it the other way. If you do it more in your head, you're going to keep to the smaller numbers, but if you're not, write them in there. Just tell me what you're doing. That's all you need. So there's some tricks that you kind of learn along the way. Do a few of each just so you know what you're better at. If you get lost with radicals, do fractions. If you get lost with fractions, keep it in radical form because you can do it either way. You can also do a combination of things. I like to do the numbers in radical form, but the variables, I kind of like the fractional form better. So totally up to you what you want to do there.